Okay, so good morning. So today's lesson, inverse functions, and we'll look at the calculus with them. So real quick, just a review, some algebra review of inverse functions. So I'm not gonna go through maybe the full explanation of the why, but I'm just gonna remind you on some definitions. So first of all, two famous inverse functions that very simple that we can think of. If we do f of x is x cubed, its inverse, which is written f inverse of x, is cube root of x. So I'm going to remind you on the three ways that we know that they're inverses. One is how to show it graphically. The other one is how to prove that they're inverses. And the other one is how to find one. So those three things I want to go over. What are the graphs of inverses look like? The second thing is how do we prove two functions are inverses? And then the last one is, given a function, how to find the inverse. Now this is a pre-cal review. We would have covered this back in chapter 1, and pre-cal is actually section 1.6. So from pre-cal, it's section 1.6. Okay. All right. So let's look at these two graphs and see what we see. So if we graph x cubed and cube root of x, so x cubed is like this, and I'm going to graph both of them on the same axis to see what the behavior is, see what the, here's cube root of x. So cube root of x looks like this. Okay, so there's f inverse. And so I put both on the same axes to see. And there is a symmetry there. And the symmetry is about the line y equal to x. So if I draw the line y equal to x through here, and if I were to fold each graph or flip each graph about y equal to x, it should land on the other graph. Okay, so that's the symmetry that we have. So for the graphs of inverses, they are symmetric about y equals x. Okay, so the graphs of inverse functions are symmetric about y equals to x. All right. I should have added a fourth thing here. I want to look at the behavior numerically, because numerically is important. So what happens numerically with points, with coordinates for inverses? So Eli, give us a point that you know is on x cubed. Like, give us a coordinate. Like, pick an x, plug it in, get the y, pick one that you know. 0, 0. So you can see, if you look at this picture, both functions have 0, 0. All right, so they both share 0, 0 because of you cube 0, you get 0, you cube root 0, you get 0. So both have that. How about when x is 2? When x is 2, what's the y value on f? On the f function? 8. 8. Yeah, so it has the point 2, 8. So what I want you guys to see is that when we're dealing with symmetry, there's always a mirror, there's always a reflection point. Okay? I call it the mirror point. So the mirror point, so when you flip here, there should be a point that's related to this one. Okay, so the question is, what point do you think that this is on the inverse function that would exist on cube root of x? Anybody can answer. It's 8, 2. And that always happens. That is an always. So if 2, 8 is on f, 8, 2 has to be on f inverse. Okay? So numerically, what happens? If AB is on F, then BA is the mirror on F inverse, okay? So that's the rule, that's the numerical relationship there, okay? And we could do more, like the other one I usually do is, say 327 is on F, way out there should be 27 comma 3. Okay. All right. Now these that intersect, they intersect on the y equals x line. So those should be the same coordinate. And what are these? So that one was 0, 0. What point do you think this is, Ivan? Do you know what this one? What point do you think that they share? Anybody can chime in.
1, 1.
It's 1, 1, right? And then what do you think this other one is?
-1.
Yeah, -1, -1, because the cube root of -1 is -1. -1 cubed is -1. So it doesn't matter if you switch x and y, you're going to see the same. Okay? So what do we know? The graphs are symmetric about the line y equals to x. Numerically, if we have a point AB, BA is the mirror point. What else do we know? All right, so here's the review I want to do with you here. If I didn't know this function, right, how could I find the inverse just given this function? So we're going to go through that. So given f of x, how to find the inverse. And so here's what we do. We have f of x is x cubed, which we're going to go ahead and make it y equals x cubed because it's simpler to work with x's and y's. And so the first step we do, so this is how to find the inverse. So I'm doing number 3 over there. So the first thing we're going to do is switch all x's and y's, because that's what happens. That's the characteristic as you go from a function to the inverse, the x and y switch. So you're going to switch the x's and y's and then solve for y and see what you get. And that should be how we should get that other function that we saw before. Okay. Going crazy. And this is always the rule to find the inverse. So it's 2 steps. So first thing I do is I switch to x's and y's. So I'm going to get x equals y cubed, because that's what we see happens numerically. Then I'm going to solve for y. Well, the only way I can get rid of the cube is I have to do what to both sides? Cube root. So I do cube root of the left and cube root of the right. So I get cube root of x equals to y, and that is the inverse function. Okay. So given a function, how to find the inverse, there's that. Okay. And like I said, we did these 4 things in pre-cal last year. So I've shown you, we went over the rule for with graphs. How do we find the inverse? We've done that numerically. What's the rule? Now the last thing to do is how do you prove 2 functions are inverses? So I'm going to give you another 2 that, well, I don't want to keep using this one every time. I'm going to go ahead and erase this picture. All right. I'm going to give you another 2 functions, and I want you to prove that they're inverses. All right. And so I'll go over the rule for proving real quick. So let's just say we'll call this example 1. Given f of x is 2x minus 1, and g of x equals x plus 1 over 2, prove that f of x and g of x are inverses. Now, we're not gonna take one and switch x and y and find the other one. There's a way to just prove, and here's the proof. So the proof is this: to prove 2 functions are inverses, this is what has to happen. If you do composition, if you do f of g of x, you should reduce and simplify to x. Or if you do g of f of x, you will get x. So the other way I could have written this is f of f inverse of x has to equal to x, or vice versa, f inverse of f of x. So do a composition, take g and plug it into f, and see if it reduces to x. If it does, then you know that they're inverses. So we're going to do this first, we're going to try with this first one. So we're going to do f of g, which means we're going to take the g function and plug it into f in place of x. And through simplification, we should get x. And that has to do with the x and y switching. All right, so I'll work through this with you. So g is x plus 1 over 2. So I'm going to do f of x plus 1 over 2. So what happens is exactly what I diagrammed. This function goes into f in place of x. Okay. 2's cancel. You get x plus 1 minus 1. 1's cancel. We get x. And that's it. That's just a way to verify. Verify and prove are synonymous in math. We verified that those two functions are inverses. Now, could we still go and do the find real quick? We can do that. What's something I could do quickly to just double check that they're inverses? What's a quick, like rather than doing this, what's something I could do numerically to see if they're inverses? Yeah, pick a couple of points. So let's just say I pick 2. If I plug in a 2 to f, I get 3. So if 2, 3 is a point on this one, then what has to be a mirror point here? 3, 2. So let's see, if I plug in a 3 here, 3 plus 1 over 2 is 4 over 2, which is 2. So yes, this is a point on f, this is a point on g, and we can see that we have that relationship, okay? All right. So this is how you prove. So what happens if you go through this proof and you don't get x? What does that mean? One possibility is they're just not inverses. The other possibility is what? Assume you are not perfect. You made a mistake. Do it again. Check. So either you're correct, Graham, they're just not inverses, or the other one is I made a mistake somewhere. Let's go and check. Okay? All right. So let's do this one. We'll do two problems and one here. All right. So example 2, given f of x is negative 5x plus 3, first find f inverse of x, part A, then B, prove f of x and f inverse of x are inverses. And now we will start to introduce the calculus. Okay, let's check our work. First thing is I want to find the inverse, all right? So I'm going to come over here to the side, got a little room to work, yep. Y is negative 5x plus 3. So when I want to find the inverse, the first thing I do is what? I'll switch to x's and y's, and then I'm going to solve for y. So what would my first step be?
Subtract 3.
Subtract 3. So x minus 3 is negative 5y. Then I'm going to divide both sides by negative 5. Now, you can leave it like that, but I also would want to write it negative 1/5 x plus 3/5 if I divide both sides by the x and the minus 3 by negative 5. I get this, and that should be my inverse. It'll be easier to differentiate in a second when you get that. All right, so then the next thing is, so there's that, there's f inverse of x. So I've got negative x plus 3 over 5, which is negative 1/5 x, well it was, yeah, plus 3/5, that's fine. Wait, where did I make a mistake? Did I make a mistake somewhere? No, if I move the negative up, that's fine, yeah. Okay, there's that, all right. Next was prove that they're inverses, all right? So if I'm gonna prove one goes into the other, so it doesn't matter which one of these you wanna do. You could, f can go into f inverse if you feel better about that, or f inverse can go into f, either one. So I'll just do f of f inverse, so now I'm gonna prove. So f of f inverse, so let's see what we get. Negative 5 times, so if you guys had negative x plus 3 over 5, and then plus a 3, okay. So the first thing I would do here, instead of distributing the 5, is cancel the 5s. Then I distribute my minus, and I get x minus 3 with a plus 3 on the end. Those cancel, and we get x. Okay. All right. Last thing. So what type of functions are f and f inverse? Those are what? What type of functions? What family?
Linear.
Linear. They're lines. So they're lines, so their derivatives should always be the constant, right? No matter where you take the derivative, you should get the same answer. So notice what I asked on part C. On part C, I said, find the derivative of f and find the derivative of f prime. And that's how you write it. F inverse prime of x, that's the derivative of f prime. So we're finding slopes. So what did you get for f prime of x? And what do you get for f inverse prime? So Ivan, what's the derivative of f? Yeah, just negative 5. Which is saying no matter what point you pick, the slope is always negative 5. Well then now if I go to f inverse, and I think this is it's easier to take the derivative here because 3/5 is gone. The derivative of something times x is just that something. So we get negative 1/5. So my question is, what do you notice about negative 5 and negative 1/5? Anybody notice what those are? They are reciprocals. Go back to the previous problem that we had inverses. F prime is 2, G prime is 1/2. Reciprocals. Okay? Now, that's for all x. Let's do this real quick. Let me make sure we got, does everybody have this right in here? And again, I'll send the video. You got a question somewhere, Eli? Okay. So you can, again, watch this video. You can go through it like that. Now, this is what I want to show you. And this will be a 2-part lesson. We'll do part 2 tomorrow. I'm just introducing the calculus part. So we have these 4 parts, but there's a calculus aspect of this. So now, let's go back to our original 2 functions that we know our inverses are x cubed and our cube root of x. So here's what I want you to do now. So this is example 3. Given f of x is x cubed and f inverse of x is cube root of x, find, part A, find f prime of x and f inverse prime of a. So now you shouldn't get numerical, you should get functions because those derivatives are not constant. So find the derivative of each function and then we'll go from there.
Just go to YouTube and do that?
You're welcome to come in.
I don't want.
You're fine.
We don't have to clean the desk because I was in here all day. You know how it is.
You got that stuff there. Yeah. This is Dr. Martin from the central office. He's just coming in and saying hi.
Y'all are lucky. You have the best.
So we're not live, so we just film it, and then
Okay.
so what they do is I get a better quality if I do it, so I film it on my laptop. As soon as class is done, I upload it. And I said, so not live, but we're filming this, like this. All right, so let's find each derivative. All right, so what's the derivative of f? What did you get? We'll go with Bruce here. What'd you get there?
3x.
All right, 3x squared. So let's just save it. So we got f prime of x is 3x squared. Now, how are we going to find the derivative of f inverse? Because it's cube root. What do we need to do?
X to the power of 1.
Yeah, make it x to the 1/3. So the first thing I'm going to do is make this x to the 1/3. And before I go and do derivative, I need to I'm going to do derivative like with this, but so we got it to the 1/3. So what's it going to look like here? So the 1/3 goes in front, x. We subtract 1 from the exponent. What would it be? To the negative 2/3. So 1/3 minus 1 is to the negative 2/3. Okay. All right. So then my rule is this: anytime I have a derivative, don't leave it with a negative exponent. So I'm going to make it 1/3 x to the 2/3. Okay. All right. So now, here's what I want to show you. What's going to happen at mirror? So right now, that's that derivative, that's that derivative. Notice you see the 3, you see the 1, you see a 1/3. So it's starting to get me to think maybe about reciprocals a little bit again. So what we're going to do is, I want us to find the slope at mirror points, and I want you to see what happens. So we're going to find, so the slope on f at 2,8, and the slope on f inverse at 8,2. So if you can kind of look there, we see that both, what's the slant, what's the sign of both slopes? Are they both positive or both negative? They're both positive, but you can see one's steeper than the other one. So let's see if the same, what was happening before keeps happening. What was happening on lines? When I did my derivative of each line that were inverses, what happened with the slopes? They were reciprocals. So now what we gotta do is, I've taken my derivative, these are not reciprocals of each other, but let's see what happens when I plug the point in. So what we're gonna do is, on this one, we're gonna do f prime of 2, and over here we're gonna do f inverse prime not of 2, but we gotta do it of what? 8, because 8 is the mirror x, right? See, this is the 0.28, this is the 0.82. I want you to see what happens. So find f prime of 2, find f inverse prime of 8, and then do the other mirror point on your own and see what happens with the slopes every time. And then I think we can draw a conclusion. All right, how do you do a 2/3 exponent? Well, here's what I do. When I have it to the 2/3, I do cube root, and then I square. That's how you do 2/3. Or you can square and then do cube root, either one. But I would cube root and then square it, okay? So let's see, f prime of 2, 3 times 2 squared, we get 12. So before I even work the problem, what answer am I anticipating over here? If I go with the trend, 1 over 12, the reciprocal. So let's see. So f inverse prime of 8 is 1 over 3, 8 to the 2/3. So you do cube root and then you square. Well, cube root of 8 is what number? 2. 2 squared is 4. 1 over 3 times 4 is 1/12, and there's the relationship again. So let's do the last mirror point. So I'm going to do f prime of 3, and I'm going to do f inverse prime, not of 3, but of what? The 27, yeah? And plug both of those in and see what you get. And then that will be our last bullet point. So I'm going to erase these, and I'm going to put 0.5, bullet point number 5 on inverse functions. Okay, so let's see. F prime of 3, you got what? 27. So what am I anticipating should be the slope at the mirror point? 1 over 27. So let's see, so it's going to be 1 over 3 times 27 to the 2/3, and the 2/3 of 27 is 9. Cube root of 27 is 3, 3 squared is 9. 1 over 3 times 9 is 1/27, and that is an always. That's always the relationship. So I put, if AB and BA are mirror points for F and F inverse respectively, then F prime of A is 1 over F inverse, F inverse prime of B. I'm basically saying that those slopes are reciprocals, okay? So if you have F, you have F inverse. Let's say this slope here is K, then this slope here has to be 1 over K. Those slopes have to be reciprocals of each other at mirror points. Okay. All right. So we'll stop there. I want you to go in and explore the assignment. It's available 2/6. And there'll be some things I did not touch on. The things I did not touch on, I will touch on tomorrow. What are those that are lacking? The discussion of one-to-one functions is important. And then also, these inverse functions, what if we, the question is, what if we can't find f inverse of x? What if we can't find it? How are we gonna solve this problem? Look, when we can't find f inverse of x algebraically, but we still wanna look at slopes, okay? So what if we can't find f inverse of x algebraically? These things that we'll look at, these topics we'll look at tomorrow, we'll break it up over 2 days.